Okay. So today's session is about understanding what is TDD or test-driven development in Java. How can we do that? And what is the benefit of using TDD and why you should be using that into your development practice? So let's understand test-driven development with an example and definition. Then we can look into first a definition example. Then we can look into what is the definition of TDD is. Then we can see what is not test-driven development, why the need for test-driven development has came from, and how can I use test-driven development and how can I use effectively that. So what is test-driven development? So it's basically TDD does is a design approach for your testing, which will help you do very short and rapid development. So first part of test-driven development is what is you're not going to write your source code, rather you're going to be writing your test cases first. So when you write your test cases is going to fail. Then you write the corresponding code for that. That is the implementation code. And after that, you do further refactoring of that implementation code. And again, you add new test cases to it and your code get failed. And again, you write the code and you refactor. So what is basically makes the developer to put the test cases at first, and as you put your test cases at first, what benefit you're going to get is your code is always testable, and then your code or your implementation is always being written as per the design that you have understood. So you should be having your design first, and then according to the design you write your test cases and then you implementing your code. So there is a very little deviation from your design, and you can always can improve on your design that is there. So here is a simple requirement. We need to write a method where we have to write, take a password, and you validate few things about the password. That is, it should be between 6 to 10 character long. It should have at least one digit, and it should be at least one parameter. So if these been your dependency requirement, right? Then what you're going to do first? You're going to basically write your unit test case first. So we're going to be using JUnit, and you're going to be annotating your particular test case. Say you give a particular test case name test password validated. So here is basically, or you can write password validated test. And there you have a method validate the length. So here you are checking the first requirement. whether the length should be between 6 and 10. Now here you are creating a password validator, and then you are asserting that you're passing a 6 character and you are asserting that it is valid. Okay, but you cannot run your test because there is no implementation class. So when you run this, when you see this, your test is not even going to compile. So that means you are not even writing your implementation code or the class file even before you writing your test case. Okay, so your test case is first. Now the test case doesn't even compile. So now you only need to write a password validator class and the default constructor. Now after that, if you come back to this particular test case, you find the is valid is false. Okay, so is valid doesn't exist. So you write only the specific code that is required for this particular unit test process. So you put BV is valid and you put a instance method and it takes and it returns true or false. Now if you run this, by default you say false, so it will get fail. So now what you have to do, you have to apply the minimum logic to make it pass. So you're going to only write, you take an argument string and you take its length, whether the length is greater than or is equal to 6. Then you find your test case is now passed. Now comes the refactor part. Do you need to create a constructor or object of this class? So every time the test case method runs, so what are the design decision you have to test? What is the class name? Whether you should have a constructor? What is the method name? What is the parameter? What is the return type? So those design decision you are being driven by your test. So your test is driven your design logic or design decisions. Now, after you write this, you write the password length is greater than is equal to 6 and it is greater than less than is equal to 10, then true, else false. Or you can write in a single line, return password length is equal to this. That's also simple. Now, after that, your test case get to pass. Okay. Now comes the refactor part. So, what is the refactor part going to say? Do you really require an instance of this class? Then you can say, no, we don't require an instance of this class. I can make this particular class as static class also. Static method also is valid. So what I'm going to do, I'm going to next go into the particular method and I'm going to be changing this. So design decision is using the static method. So as I make the static method again, our compilation going to fail. As the compilation going to fail, what you need to do, we have to go back and we have to refactor our code, make that particular code into static. So what is refactoring? So refactoring is nothing but you're changing the structure of your code without changing its behavior. So that means, example that we extract the method, we extract interfaces, we pull up or push down methods, we make that particular thing inline. So any IDs or our IntelliJ also gives us ID for refactoring. So we got to have rename, etc. that you can do from the refactor menu. After refactoring, what happened is this has been changed into static and your code behavior doesn't change or your test cases do get passed now. Now the question is, can you further simplify this particular line? Okay, we can simplify this by combining these two conditions using and removing the if and else. So your refactoring is now getting completed. Now also another set of refactoring we can do is that we are using magic number or we are using literal. So we can be, if you need to change the logic, then we have to update the code, right? So we can define some constants and use that. We can define within the class the constant, and again, it's not going to change any of your behavior. but it's going to be changing your source code that is there. Okay. So now after that, what you're going to say that it is a valid length. Now you're going to put another condition whether it is less than 6, then you can put it is greater than 10 or within that. So those logics you can put, those additional test cases you can put. So that will ensure that all of your test cases are being covered properly. Now the next requirement, so if we go back to our requirement, so that take care of our first requirement, that is 6 to 10. Now the other two requirements are at least 1 digit, right? So then we can go back, and here we are not passing any digit, we are just passing A, B, C, D, E, F, and we are expecting it to be false. Now again our test case get false, because again the implementation logic doesn't exist, because we have written the test cases false. So it's become red. Now to make it green, I have to go back to my source code, and this is my test case that is currently do exist. Then I have to add an additional condition. I can use pattern matching is equal to regex, and there I can put the p digit, and it should be at least match one or more digit. So that will the particular pattern matching I can add. Now the all of my test cases will get passed. So that is the pattern matching that is being put out here. Now, can we again do refactoring? Yes, we can do that. We can break this particular two condition into two different methods. So we can extract this pattern matching into a method is digit present or something like that, is minimum 1 digit present, whatever name we can give it, because our behavior not changing, it is all becoming now private method. And then we can give the first two condition, that is password length valid, or is the password is minimum length and maximum length is valid. So we can again extract that out into two different methods. So one is this given as a contains digit and contains digits out here, and another one is given as a valid length that been now combined. Okay. So now up to this, any question you guys have? How the case driven development works?
No.
Okay. So now if we look into the definition, right? So here we are going to be writing automated unit test cases. You can write automated unit test cases or integration test cases at is. And of your code. So that means those automated tests will drive your design decision and programming uh, structure. Okay. And for every feature, right, every functional feature or requirement, you're going to be covering that a test. So that what that ensures? That ensures that your code is tested for every and each condition that particular method or particular component or particular service need to support it. So that means your code is always tested. And then you only write exactly that amount of code that will let your code to be passed. So if I need to write the previous example, right? So first we have written the first condition that it should be within that particular length. Next condition is that at least 1 digit should be present. Okay. That condition may be something we can further written out here. If you can look into the whole requirement again, at least one uppercase character. Then we can put another regex. It's the is uppercase character present. Just like this, contains uppercase, and then that much code paste we write. Okay, and then after that we always refactor. Only writing test cases and only making it pass will not help us write clean code. We always need to come back and refactor our code, make it simplified. And this we can do it for both of our implementation code as well as our test code. So just to simplify the definition, you write test cases which drive your design decisions and implementation structure, and after you write your test cases, it's going to fail because there is no implementation present. You write enough implementation to make it pass for each functional point one by one. You don't write all the test cases at one go. And by this, your all of the test cases supports your every points of functional requirement. And thereby, after that, important point is always do the refactoring of your code. Okay. So that's the definition. So what are the steps is known as rate, green, and refactor. Rate being your test cases are currently failing, green being your test cases are passing, then you are doing a refactoring. And that will help you clean up your code, remove duplicate, etc. So now we know this kind of testing, right? So unit test is where we basically focus on TDD focus out here, right? We can also use TDD, also your integration or functional test. Also for regression test, we can also use TDD, like we have use fitness or fit fixtures, or we have used cucumber or JBehave or those kind of things, right? Regression suites you can also write. Stress loss testing, not much, but on the first three cases, certainly unit and integration cases, you can adopt the test driven design and development. Okay, there are some misconception that it is all about testing. That is not. It is basically focusing on getting your design right. As a part of this, what you are doing is you are just having as a byproduct that test. The unit tests are being written first up. That's all. But it's always about getting the design correct and doing the refactoring or further improving your code. Okay. Again, TDD doesn't mean that you're going to be writing all of your scenarios, all of your requirement tests at the first. You rather go one scenario or one functional requirement at a time, and then you write the minimal code to support that. So it's gradually you're going to build in your features one by one. So one test case, it's failed. You write implementation, it is passed, refactor, then come back, write the second test case. So that means whenever, as you are by short iterations, you are adding more code, you are ensuring that you are doing the refactoring as well. Okay. So again, TDD also not about you are writing some part of the code and then making your test parts. You only adding the tests one by one and adding the minimal code to pass it. Not all, not some code. It is one code, one test case, one particular feature at a time. And also TDD doesn't mean you start by writing some code, then you move to the testing. TDD means that you write your test cases without even there is any class or implementation class do exist. So even if you forget about your test cases will be passing, your test cases Your code will not even compile. Okay. So no code before your tests. So again, TDD doesn't mean that automation testing. It's mostly it's about design. It's not about automation testing. Automation testing is a outcome, one of the outcome of implementing TDD. TDD always been the design that is there. And again, TDD also not means a lot of testing. We do the minimum requirement testing that is required. Okay. So the time you spend on TDD is actually not that much. Initially, maybe you can see that it will take some time, but gradually, as you make it as a practice, it will actually speed up the development process. So it's basically practice, just like the other things. It is not something like a process like Scrum, Agile, or Waterfall, XP, not like. Okay. So TDD means okay. So TDD mean is just what I told you, that write one test, write the code to pass it, refactor in, and then you just repeat the process. That is in very simple terms. Okay. So how can we use TDD? So these are some history of TDD, how that has been came about. So we can skip this if you want. So what is where the test driven programming comes? Test driven programming comes between your pair programming and your continuous integration, customer feedback, acceptance testing. This it is basically part of your development practice. When you develop, at the same time you do the test driven development. So how the TDD comes in your SDLC lifecycle? So first of all, you get a high-level architecture design, then you have detailed design, then you do coding and unit test cases, unit test, and then you have the test being created. So that is normally your uh, first. The upper portion is your normal flow. First you write the code, then you write the unit test, then you write your test. Right. Rather here. The modified SDLC, what you do, you get the high level design or architecture. Rather than creating a detailed design document, you use your test as a design and coding phase, right? So you write your unit test cases, which drives your design and the coding implementation. Then you do the refactoring, and then you add the next unit test, and like this. So that's how the TDD modifier, when you apply that with a SDLC lifecycle. So we can skip this one. Okay. So why people use TDD, right? Everybody has that. So this is some statistics that given the data about different companies using TDD, etc. uh, what is the benefit of that. Okay, we can skip this. Why you need to do the test driven development? So it obviously first thing what it claims or every promise is that automation tester give you immediate feedback. So that means you're going to have test coverage from the beginning, and you're going to be encountering defects early in your development lifecycle. And you can always do the refactoring of this. And you can better design, so you can try to, as you're doing refactoring, so you're not writing duplicate code, you are reusing your code. Okay. Focus on the use of the code, not actual the implementation. And you use TDD, so that help you to create less coupling between the component and core cohesion. It obviously increase the test coverage because you are writing the test from the beginning. And test also helps as a kind of documentation for your code. Okay, so if another team member comes in and a code, he or she first can look into the unit test cases as to figure out how the functionality actually works. Okay, and the unit test cases, when you are using Gradle and other tools, they can run the unit test case in parallel, which can be right. And obviously, byproduct is your, as you become more test driven development, your code is also become more clean. So this thing we can skip. Okay. So now here is just the options of how people have voted to using the test first or code first option. Okay. So here's the blue is basically test first, and the red is more or less test last. So here is showing the how the experienced programmer choose and how the beginner programmer choose. Okay, so they basically mostly the beginner programmer try to write the code first, and the experienced programmer wanted to write the test first. That is a basic difference. So here it's like difference between 11% versus 63% that is there. And when you do the code for test first, you're going to be ending up with fewer defects. You have more simpler code. You have more correctness of your implementation. You have more thorough testing. You choose the best approach, and that's benefits you when you delivering your code that is out there. Okay. Now here is another statistics of the beginner programmers who are choosing first graph is test last, and beginner programmers who are choosing test first. So comparatively, we find there is again 21% comparison that going to be choosing test first, and thereby they get a better result on page approach and throughput and correctness compared to the other people who are starting phase of their coding development journey, and they're choosing test last. And this is the just the graph and differences for mature developer or experienced developer. Okay, so this is like one organization, and what they have done, they have like a small group of teams. They have informal courses. They have many Java web application. So how they have experienced when they have taken the TDD as their learning curve. So they find the TDD learning curve was there, but still they have able to get higher quality comparatively when they're using the test last approach. And they also find over a period of time, whatever the code they create, they are very simplified to maintain. And some of the apps, they don't need to touch for months. And test provide a documentation as well as a safety net for detecting bug early rather than at the late as a production. Okay. And this is the same organization. Another thing was, this is another organization which is providing COTS solutions. They have used TDD with processes like Scrum, and TDD are basically help them to move faster. They able to use the continuous integration with their build servers, and code coverage was their primary metrics or code quality. So how we can try the TDD, right? We require some time to understand, okay, with TDD. So basically, we can start with a small scale. We may try to TDD for a single class or single service or single component, see how it goes. Okay. And we can spend some time to see whether over a period of time is my code is having much lesser defect, or I'm able to confidently write code quicker than what I previously used to do. Are there more maintenance I have to do in my code or not? Okay. Or my code is able to, I'm able to getting the defect early on rather than they been, find out when they are in QA or staging or even production, right? And also you can write test, and if you are using any external libraries that you can also use, and you can pair up with a senior person to guide you through the particular mentorship of writing adapting TDD as well. So TDD you can use also to understand or actually implement the design patterns, because it's all about design, right? So be it dependency injection or test bus, and for TDD we know what are the tools are. Is in Java case it is JUnit and Mockito or Mock that we are using. Okay. We can also use the TDD test cases into our build and integration project, and then we can learn about the more about the TDD patterns as well. What is the test bus architecture, right? Okay, so this is about tests which are doesn't go through the UI. Anyhow, we don't use the UI. It's like an older concept. So a testable system that can be access the API without going through the UI. So this is like older pattern, so we can ignore that. So what are the different TTD pattern we can follow? Okay. So if we have the requirement, if you're starting from the first, if you are not all the time may understand like what are the test cases or what are the scenario I need to cover, you can simply by starting by writing them on a paper and focus on, okay, so I have to cover all these 4-5 scenarios, right? 4-5 requirements I have to cover them, right? And then for that, what I have to do is I have to write the test if I require one at a time. And if I going to forget about those things, I can note it down in a notepad or a paper or whatever. Now, when you're writing your test cases, you figure it out what should be your assertions will be, right? Because based on the assertions, your test cases will be different, right? So in our example, one assertions may be there should be at least one character. There should be at least one number. There should be at least one assertions will be always true or false. But the scenario that we are taking care of is that particular scenarios, or for that particular scenarios, what are the assessment statements I have to put. So that we need to figure it out. And write your test, or explicitly write your test at a way so other developer can first, instead of going through any kind of documentation, they can go through your test cases to understand how the particular component works. Okay, so you can learning about test cases by looking into how the external libraries or open source libraries have written those tests that you can do. So, but this last one, regression test, is not for us, it's more or less the automation team will do. So whenever there is a report has been covered, they write the Cypress automation test or regression suite, they can write it, not for us. Okay. So if you are having a issue where you cannot further refactor, right? It is okay that you can, start over that particular code, piece of code, right? Because here the focus is on the design. If the design is right, you can get it written quickly, right? Other thing is clean check-in, right? So that's also right. You cannot check in any code unless your all test cases are passed. Okay. So before you check in any code, you should be, as a part of the TDD practice, you should check in your code, see your test cases are passing, then you only check in your code. Okay. Bookend test means, okay. So say for example, if you're only working on a particular component, right? And you have forget, so in a day you cannot complete everything within a day, right? So you can keep some of the test cases, you can write those test cases there, keep the test cases there which are failing. So when you come to the next day, if you forget where you need to start to, you can run your test case and you see, okay, this feature I have not implemented, so that particular feature I can start implementing and then I can execute that. Okay. So these are the some of the design practice that is there. Any questions so far on how we can implement the TTD in our code? So this session is not about how to write unit test cases. It's how to adopt the test-driven development practice. Any question on this?
No,
So
from my
in case if there is a change in the business requirement, then we have to again start it all over.
Uh, if there is a change to the business requirement, right? So, so I
Then
going
we
to be
have to change
adding the,
the.
yeah. So I going to
Then we
be
have.
adding the test case for that particular business requirement. Okay. So for that, what going to happen? Your test case going to fail because currently your implementation logic doesn't have that particular business requirement implemented. Then you have to go back, implement your business requirement, you make your test case pass, then you do the refactoring. And then you can start again if you having like more than one business requirement that is there. So what is Shrudeep is saying that if I'm starting from the scratch, I can understand I will adding those one unit test case add. So now I have like a component that I have developed or some of my team member has developed and that is already there, right? Now I have to do is to add the new requirement. Then how can I go about if I following the TG? Okay. Any other question?
No, sir.
Oh, okay. So that's about the session. If you don't have anything else, we can close the call.